This is Matt, 2021, question 1D. We want to work out the area of the region bounded by y is equal to e to the x, y is equal to 1 minus e to the x, and the y-axis. So first let's try and draw this region. So we have, this is a curve of y is equal to e to the x to the exponential, and we know it wants to be bounded by this curve and the y-axis. So we need to draw y equals 1 minus e to the x. Well, how does that look like? Well, this is just a transformation of the e to the x graph, and it's a series, so we first work inside out. So we have the minus 1, which means we flip in the x-axis, which means we get this blue curve, and then after that we must translate that up by 1 because of this 1 here, which means we get something that looks like this. And we want the region enclosed by these three, this red line, this green line, and the y-axis. So we want this region exactly. Okay, and so how do we work out when this intersects? Well, they intersect when e to the x is equal to 1 minus e to the x, i.e. when e to the x is equal to half, and then taking logs means x is equal to minus log 2. So yeah, this is our intersection point, and we want to work out this blue shaded region. Well, how might we do this? Well, if you think about this, if you see visually, it looks like this purple line is crossing, dividing our blue shaded region in half. And why is that? Well, because this transformation of flipping in the x-axis and translating it out by 1 is precisely the same thing as flipping it in the line y equals 2. So this reflection in the line of y equals a half, So this reflection in the line y equals a half basically means this purple line divides our shaded region into two bits of equal area. So to work out the blue region, we just need to work out area of half this bit. And which half could we do? Well, we can just work out the top half. And what would that be? Well, that would be precisely the area, the integral of e to the x, which would give us this entire bit underneath. But we've got to get rid of this rectangle here, so we're left with this blue bit above the purple line. So, and we need to double this to get the area of the whole shaded area. So computing this bit is precisely the integral of e to the x from minus log 2 to 0. And the area of this rectangle is precisely a base times height, which is minus log 2 times by a half. So doing this, we can evaluate this integral to be equal to 1 minus e to the minus ln 2, because of the integral of e to the x is itself. And then evaluating this, we can read that e to the minus ln 2 is exactly a half. And simplifying this gives us exactly 1 minus log 2. So the answer is